Hi, welcome to our third lesson. And of course, before we go on to the specifics about the composition, the functions, the vertical difference, the horizontal difference in the movements of winds and other components of the atmosphere, let's take a look at the big picture. Let's see that the atmosphere is part of a bigger system, and atmosphere is part of the Earth system. Now, I hope at the end of this lecture, you should be able to first describe the Earth system, including the atmosphere, and second is enumerate the characteristics of the atmosphere. Now, as we know, Earth is the fifth largest planet in the solar system and is considered the largest among the terrestrial planets. It's also known as the densest planet. Now, this planet where we live in and where life exists is considered as a dynamic system. It has different parts, different components. It's a combination of interrelated, interdependent, and interacting parts forming a collective whole or entity. And these parts or components are known as, when it comes to um, the water, part of the earth, hydrosphere, geosphere, the land, rocks, and then atmosphere, the air layer, and biosphere, the area where living organisms exist. Now, these components or systems are interconnected by processes, cycles, life cycles, which over time intermittently store, transform, and or transfer matter and energy throughout the whole Earth system. And these processes and cycles are governed by the laws of nature. It includes the laws of conservation of matter, the law of gravity, and energy. So, this energy is what drives these processes that mostly or mainly comes from the sun. So I remember the written text about um, written by the chemist who said that there are seven reasons why a scientist must believe in God. And he mentioned that if the sun, the main source of energy, was placed farther from the earth, then the earth would be freezing. And if it was placed closer to the earth, then life would not exist because it would be burning all that's existing on earth and life would not exist according to this chemist. And he believes in the intelligent design. So if you will also take a look at your body system and in all systems and all creatures here on earth, you will notice that there is a system, there is a pattern, a design, and it's well organized. Take a look at your cell, the components of your cells, the biomolecules, up to the largest components of the earth as a system. So these are well organized. It has specific functions, and these are composed of different parts, interdependent, interrelated, interconnected. Now, Earth as a system. Let's define first what a system is. So a system is basically composed of parts which functions together and has a specific purpose, and it transmits energy. It has some exchange, and these exchange serves a specific purpose. Now these two types of systems is called open systems and closed systems. So when it comes to the discussion of, yeah, the environment, the earth as a system, one is the open system. Both energy and matter flow into and out of the system. Let's take a look at the sun and its interaction with the earth. So the energy from the sun and flows into and out of the system. Some are reflected, some are absorbed by the earth system. Now we also have closed system. Energy moves freely in and out, matter does not enter or leave the system. Now, what could you say about the Earth system? Is it a closed system, an open system? Now, Earth universe systems is part or influences the Earth systems and the components of the Earth system, which includes the atmosphere, hydrosphere, geosphere, and of course, biosphere. Now, the Earth interacts with extraterrestrial bodies aside from the Sun. There are other um, celestial bodies. Okay, we also have the Moon and other asteroids and such as those. It has minor or major effects on the Earth system. Earth is part of the solar system as well, and it orbits around the sun. So we are also a part of a bigger system. Now, of course, as we know, sun is the source of most of our energy, and these affects the seasons, or should I say season is just the term used to refer to the result of these variations in the amount of solar energy received coupled with the tilt of the Earth's axis. And it's considered that every month or there's a difference between the variations of the amount of solar energy received with the movement of the Earth. July, Earth is farthest from the sun. In January, Earth is closest to the sun. Some kinds of matter, such as air, transmit most of the energy from the sunlight. Other matter, such as ice, mainly reflects energy, and others, such as rock or water, absorb a lot of the sun's energy. And we know that planet Earth is said to be a unique planet because it is mainly composed of water compared to other planets. Around 70% of our planet is composed of water, and the ocean is the main um, component of the Earth that absorbs the sun's energy or heat. As you look at this illustration, you will notice that some energies are absorbed and some energies are reflected. Okay, so extraterrestrial influences are here. We experience that. It can be drastic and also unpredictable. However, these observed external effects are already known, and some of these will be discussed in this subject, meteorology. But mainly we'll focus on the atmosphere as part of the Earth system. Now, the atmosphere is characterized as it's dynamic, ever changing, sometimes also unpredictable. Its characteristics are quite different from place to place. That's why we have what we call weather and also some known mm, characteristic or the weather in its long term is called climate. That's what is the characteristic what's happening in that place at a certain month or season. Let's say 4 seasons. Some places have 4 seasons, others have 2 seasons, and there are different climates. It's also changing in different places. So it's subject to subtle movements such as a gentle breeze or violent motion such as tornadoes. So we also have those what we call monsoons and other wind movements observed in this subject. um, Atmosphere is, as I mentioned, is a mixture of gas molecules, suspended particles of solid, liquid, and also falling precipitation. Now, quickly we'll take a look at the gas component of the atmosphere. Around 79% of the atmosphere is composed of nitrogen, 20% oxygen, and 1% argon, and there are trace amounts of other gases such as carbon dioxide. Okay, so the atmosphere, it it has specific functions aside from it envelopes the Earth. It protects the Earth from the extraterrestrial bodies. It also regulates the flow of solar energy to and from the Earth's surface and transports heat and water vapor from one region to another. And another function of the atmosphere is it shields the Earth's surface from high levels of ultraviolet radiation. So this ultraviolet radiation has an effect on living organisms, specifically to humans. So discharged particles from the sun, small meteors, and cosmic rays has an effect on our skin. So some of these are some harmful effects of UV radiation. Charged particles from the sun, cosmic rays, and meteors are the following: sunburn, tanning, premature aging of the skin, suppression of the immune system, eye damage, and what's worse is skin cancer. Now let's take a look at these layers, these protective layers, starting from the outermost part, the exosphere. The next is the thermosphere, the mesosphere, the stratosphere, and the troposphere. But as I've mentioned a while ago, compared to the Earth's cross-sectional size, the thickness or the depth of the Earth's atmosphere just adds less than 2%. Okay, so it's considered thin compared to the Earth's cross-sectional size, but it protects the Earth from the outside and also from what is happening below it. So atmosphere is not the only the air that we breathe, but also the buffer that keeps us from being peppered by meteorites and also a screen against deadly radiation. And the reason radio waves can be bounced for long distances around the planet. So it has an effect on our media and short waves. So let's start with the lowest layer of the atmosphere. So troposphere is characterized as it extends to only a height of about 11 miles or 17 kilometers. And it contains 4/5 of the Earth's air and it provides most of our weather. Okay. The higher you go in the troposphere, the colder it gets. So if you will take a look at the geosphere, the deeper you go, the hotter it gets. For the troposphere, the higher you go, the colder it gets. Next layer is the stratosphere. It extends to a height of about 30 miles or 50 kilometers, and it includes the ozone layer. It blocks much of the sun's harmful ultraviolet rays. It's warmer than the troposphere because of the energy from the ultraviolet light absorbed by the ozone, and so on and so forth. So at its top, the temperature drops nearly to freezing level. Now the mesosphere drops again down to nearly negative 180 degrees Fahrenheit or around negative 120 degrees Celsius at the top. Okay, so meteors generally burn up in the mesosphere. Next is the ionosphere. It's also called the thermosphere. And what's special about this layer is that satellites orbit within this layer. And it's called ionosphere because it's named for the ions. It's created within this layer by energetic particles from sunlight. And it creates an electrical layer that reflects radio waves. So the ionosphere also create the auroras called the northern and southern lights or the aurora borealis. And the last layer is the exosphere. It's the thin portion of the Earth's atmosphere extends outward until it interacts with the solar wind. So solar storms compress the exosphere. So it's said to be estimated that it ends about halfway to the moon. So these are some general information that we will further discuss. And I hope that you will be able to distinguish and know that the atmosphere is part of a bigger system, the Earth system, and its interaction with the outside and the inside has an effect on this particular layer or covering. And the atmosphere is very important. It is a shield, a buffer, a screen, and it's a protective layer. So let us take good care of this layer, and let us further know how um, our daily tasks, our interaction with our environment, with other spheres affect the quality or the characteristics of the atmosphere. So once again, thank you for attending this class, and you may just send me a PM or a message at our GC for further questions. So thank you, class.